Yes, sorry, just to correct, I mean here the upper limit is square root of pi over 2, because, it didn't make a lot of sense just with the pi over 2, so that's now no problem, because you have the sine of the square root of pi over 2 squared, so that means it's just the sine of pi over 2, so the sine of pi over 2 is 1/2 over 2, so that's 1/4. And then, you have to evaluate at 0, so the sine at 0 is 0, so all of this becomes 0, so the final answer, it's actually 1/4 minus 0, so it's 1/4. Sorry about that. Here it was square root of pi over 2. Okay, so now let's go to the next problem. So next problem is problem 43. For problem 43, we have to find the dy over dx of the function y, which is given by the formula definite integral from -1 to x t squared over t squared plus 4 dt minus 3 to x, the definite integral from 3 to x of t squared over t squared plus 4 dt. So this has to do with the first part of the fundamental theorem. So, what is the first part said? It says that if a function is continuous in a closed interval from a to b, and x is between these 2 points, we have that if g of x is equal with f from a to x, then we have that g prime of x is equal with f of x. What does the first part of fundamental theorem of calculus says that if a function it's continuous on a closed interval from a to b, and x is between these 2 points, and you have that g of x is equal with definite integral from a to x of f of t with respect to t, then you have that the derivative of the g of x is equal with f of x. So here we actually we know that this function here, it's continuous everywhere. Why this here is continuous everywhere? Because this function here doesn't have, the denominator, it's a quadratic with a negative discriminant. If you calculate the discriminant of this is negative, which means that this here doesn't have any roots in the. You can choose any closed interval where x will be included. Okay, since it's continuous everywhere, so that means that we can apply this rule here, because we have that the y, which is our gx, is given by this formula. The first part, if you compare it with this here, you get that your f of t is this here. So that means that the f of x, it will be exactly the same, but whatever t you will put x, so that means this will be x squared over x squared plus 4. So, and of course the same thing applies for the second part, because it's exactly the same function. So if you want to find the dy over dx, which is the first derivative of the g function, so that should be for this part here, it will be, so for this part here it should be this here. And of course for this part, again with the same rule, it will be the same thing. So this cancels with this, so the answer to this is that it's equal with 0. Now the next problem is problem 47. We have the function y is equal with minus x squared minus 2x, and we have to find the areas enclosed by this function, by the graph of this function and the x-axis. So in the interval between minus 3 and 2. So, what we'll do here, here if you want we can do a small graph, so you have to know how the graph looks in order to find this kind of problem. So if you do the graph here, so this is a parabola. It's a parabola that opens downwards because because the coefficient before the x squared is -1. So, and if you set this here equal with 0, what you will have? You will have negative, so let's say this is equal with 0. Now if you factor this, what you will have? You will have negative x, and you have inside x plus 2. So if you set this equal with 0, you have that either x has to be equal with 0 or x plus 2 has to be equal with 0, so that means that x is equal with -2. So, okay. So, and if you want to actually this here, yeah, also this here, also this here passes from the origin, because if you set x equal with 0, you will have that y is equal with 0. So this graph, it will look approximately, let's say this here is -2, so -2. So that means the graph it will go like this, passing from the origin. So, and we have to find the area between this graph and the x-axis, between the points -3 and 2. So that means, let's say if this is -2, -3, it should be somewhere here, and 2 it should be somewhere here. So we're trying to find how much is this here plus this here plus this here. That's not a big deal. I mean, it's if you go back to what we're doing, to how we started this course with Riemann sums. With the Riemann sums, the area, it's the area between a curve and the x-axis is always the definite integral of the function of the curve that has limits of the definite integral. The limits of the definite integral will be the points of intersection of the graph with the x-axis. What do I mean by this? Let's first of all say that this is area 1, this is area 2, and this is area 3. So let's start from 1. So the area 1 is bounded by this curve here, which is of course it's the graph of this function, and has limits the point -2 and 0. So that means you have to find, in order to find the area 1, so let's say A1, it should be the definite integral from -2 to 1, from -2 to 0 of this function here, so which is x squared minus 2x with respect to x. So, and since we have done it so many times, the integral of x squared, it's, if you use the formula that the integral of x to the n is equal with x to the n plus 1 over n plus 1, so that should be x to the third over 3, and the integral of, -2 is a constant, so you leave it here, and the integral of x, again with the same rule of integration, it should be equal x to the 2 over 2. So, and now you have to find this here, to evaluate this from -2 to 0. So if you evaluate it at 0, that should be 0, because if you put whatever x equal with 0, it gives you 0. And then if you evaluate it at -2, it should give you -2 to the third is -8 over 3 minus 2, and then minus 2 squared, so that's 4 times the -2, again it gives us -8 over 2, so that's actually -4. If you put everything under the same denominator, it should be -8 minus 3 times 4 is -12, -8 minus 12, it's -20 over 3. So that's area, that's this area here. Okay, excuse me. That's the integral at point -2. So in order actually to find the area 1, you just have to subtract how much is at 0, which was 0, minus how much it was at point -2, which is -20 over 3. So minus the minus, so that will be +20 over 3. So that means that the area 1 is 20 over 3. Now, you do the same thing for this part here. So let's keep the 20 over 3 here. So area 1 is 20 over 3. So area 2, it's again the same process. You just have to take the again the integral now from -3 to -2. Again, it's the same. This here it's part of this function, so you just have to do definite integral from -3 to -2 of the same function, which is -x squared minus 2x again, we find this before, so let's keep it here. So the antiderivative of this we said is -x to the third over 3 minus 2x squared over 2. So this cancels with this. So now here we have to evaluate it at -3 and -2. So at -3, so let's call this capital F. So at the F at -3 is how much? It's -3 to the it's minus the minus, actually it's minus the -3 to the third, so that's minus the minus, so that's plus 27 over 3, so that's actually equal with 9, and then you have minus the -3 squared, which is again 9, so it's -9, so it's 0. Let me double check. Yeah, let me also double let me do again the f at -2, because I think so let's write it here. So the f of -3 is equal to 0. Let's do again once more let's do the f at -2. So the f at -2, it will be minus the -2 to the third, so which is minus the -8, so that's +8. So minus minus the -2 square, which is -4. So it's actually 8 minus 12 over 3, so that's -4 over 3. Sorry. So that means that this here, if you do again the calculations, it will be 0 minus the -4 over 3, so that's actually 4 over 3. Sorry about it. Okay, so now if you want to find the definite integral from -3 to -2, it should be f of -3 minus f of -2, which is equal to 0, minus the so if you want to calculate this part here, it should be f of -2 minus f of -3. So that should be equal with -4/3 minus f of -3, which is 0. So it's minus f of 3. Okay, so that's the area A2. So area A2 is equal with -4 over 3. And finally, finally you have to find the area number 3, so which actually should be equal with the definite integral from 0 to 2 of the same function. So, because again, this graph here is part of the graph of this function here, so that means that you have to find the definite integral again of this function here, which we know that the antiderivative or the f is equal with this here. So that means that you have to find the f at the upper limit, so you have to find the f at 2. So the f at 2 is equal with minus 2 to the third, which is 8 over 3 minus 2 squared, which is 4. So all this should be, if you put everything under the same denominator, so that should be minus 8 minus 12, so that's minus 20 over 3. And the f of 0, we know that it's 0 when we did it before. So that means that the area 1, the area 3, which is equal with f of 2 minus the f of 0, it should be equal with minus 20 over 3 minus 0, so it's minus 20 over 3. So now, in order to find the total area, so we have A1, A2, A3. So in order to find the total area, we just have to, the areas that are below the x-axis, they are always, they will always be negative when you try to calculate them using this method. But actually, in problems like you want to find the net area, you can add it as it is, because it's the positive minus the negative. But in this case, because we want to find the total area, so that means it's this plus this plus this. You have to take, for the negative values, you have to take the absolute value. So that means that the total area, let's say A total, it will be the A1, which is 4 over 3, the absolute value of this, which is again 4 over 3, and the absolute value of this, which is 20 over 3. So if you put all these together, since they have the same denominator, it's actually 28 over 3. And we have one more. The last problem is problem 51. So problem 51, I give you this graph here. So here they give you this graph. So this point here is has x coordinate pi. This point here has y coordinate 2, and this here is the graph of the function 1 plus cos of x. So they're asking us to find what's the area between these two lines, so actually the red area. So, I mean, we know that, I mean, this red area, okay, we can find it. So let's say a red is, we can find it when we find all the area, okay, and we subtract. So let's say when we find all of the area and we subtract, let's say a total, and we subtract this part here, which is under the y graph. So let's call this part A1. So, how much is AT, the total area? I mean, we know that the area under a graph, it's the definite integral of the function of the graph between the 2 points. So that means that for the total area you have to take, so A total has to be equal with, I mean, what's the function, what's the function that has this here as a graph? Is the function y is equal with 2, which is a constant function, and you have to take this with respect, this integral with respect to x, and the limits are from 0 to pi. So let's find it. I mean, if you find the antiderivative of this, so let's say f capital, the antiderivative of this, I mean the antiderivative of 2 is 2x. So, I mean plus c, but you know, in this case, as in the previous problems too, I mean the c doesn't play any role. So that means that you have to evaluate this first at pi, which of course will give you 2 pi, and then you evaluate it at 0, so that will give you 0. So that means that this here, it should be 2 pi minus 0, so it's 2 pi. And now you have to subtract this area here, so that means that, you know, with the same exactly reasoning, you just have to take that A1 is equal with the definite integral. I mean, what's the graph, what's the function of this graph here is 1 plus cos x, and you have to take this again from 0 to pi, and again all of these with respect to x. And what's the, let's call it here q capital for the antiderivative of this. The antiderivative of 1 is x, and the antiderivative of cos x is sine. So, and now we have to evaluate at pi and 0. So if you evaluate, if you find the q at pi, it should be pi plus the sine of pi. The sine of pi is equal with 0. So the q at pi is pi, and the q at 0 is 0 plus the sine of 0, it's again 0, so it's 0. So that means that this integral here, it's q at pi minus q at 0, so it's pi minus 0. So what we want to find, we want to find the AR, which is AT minus A1. So it's not a big deal. We know that AT is equal with 2 pi. A1 is pi. So the answer is pi. Yeah, I forgot to tell you, of course, that, you know, like since we are following the outline of Concordia University, we're using the book Thomas Calculus. I mean, mine is the 13th edition, but almost all the editions, they are very similar. So, thank you for taking the time to view this video, and I hope you find it useful, and bye for now.